H naught is 0, H1 is 5.2, H2 is 8.7. So similarly, you will put all these values, and the area of that offset trace is 2,860 feet square, right? So that is the way if you space this offset into equally spaced distance. Now, what if you can't do that, right? So irregularly spaced offsets, right? So you want to calculate, this is the same area, right? This same area, but you cannot do equally spaced. Maybe you cannot measure, it's some area is underwater, bushes, it's not accessible, whatever, right? There can be any reason. So when that is the situation, we use this formula. Area is equal to 1 by 2 A H naught plus H1 plus B H1 plus H2. Now this A, B, C, D, in the previous formula, we have B because it was equally spaced, and in the example it was 50 feet. Now the width of each segment varies, and also height of each segment varies. So now the formula is changed, right? So here, for example, in example 2.2, you can see that this is 0, 0, and then this is 60, and then this is 140, right? So this was width of this first segment was 60 feet, and the second is 80 feet, and then 240, and 140 to 240, 100 feet. So the width of each segment is varying for each segment. Similarly, the height H naught, H1, H2, H3, H4, 5, 6, this also varies. Like H naught is 7.2, H1 is 11.9, H2 is 14.4, and so on, right? So you will use this formula where those offsets are not equally spaced. You put these values and you will calculate the area of that offset, and then you will add whatever offset is into the main area, whether those were triangles, rectangles, trapezoids, polygons, whatever, and you will get the whole area of that survey boundary. Now, area by coordinates. Like we studied in the first slide, that how we can calculate the area of any shape using the coordinates, right? All right. So this is the figure, right? This is x-axis, this is y-axis, right? A. Okay, the meeting will end in 10 minutes. So let's see, we will come back again, but let's study this figure and then we will see. A, E, D, C, B, A, or A, B, C, D, E, A. So you want to calculate the area of this figure, right? However, this is neither triangle, neither rectangle, neither trapezoid, neither polygon. So we will use the same method of dividing the area into rectangles, triangles, trapezoids, whatever we can do, and then we will calculate the area. So first we will study here. For procedure, the procedure for computing areas by coordinates can be developed with reference to figure 12.4. This is figure 12.4. All right. As shown in the figure, it is convenient but not necessary to adopt a reference coordinate system with x, y axis passing through the most southerly and the most westerly traverse station, respectively. Line BB dash, CC dash, D dash, and EE dash are constructed perpendicular to the y-axis, like EE dash, DD dash, BB dash, CC dash. This is y-axis, so they are perpendicular to y-axis, right? These lines create a series of trapezoids and triangles shown by different color shading. For example, this is a triangle A, E, E dash, and then E, D, D dash, E dash, A, B, B dash, right? C, C, B, B dash. So this is a triangle. The upper one was a rectangle. So these are the rectangles and triangles created to calculate the area of that shape. The area enclosed with traverse A, B, C, D, E, A. Traverse A, B, C, D, EA. So this traverse, the area of this traverse can be expressed in terms of the area of these individual trapezoids and triangles. Now, area of A, B, C, D, A is equal to, these are certain expressions, right? So let's see how these expressions are. E dash E, D, D dash E dash, E dash E, D, D dash E dash. So this triangle, right? E dash E, D, D dash E dash. So this is this area, these two shapes, right? All right. Plus D dash D, D dash D, D dash D. So D dash D, C, C dash, C, C dash, D dash. So this whole area, this whole area. So this plus this is the whole figure, right? But we want the area of this shape, right? So we have to subtract this area, this triangle area, this rectangle area, and this area, and then we will get the this shape area. Minus A, E dash E A, A, E dash E, A. So this area will be subtracted, okay? Minus C, C dash B dash B, C, C dash B dash B, all right, C. So we will subtract this area, and now this is remaining. We will also subtract this triangle. Minus A, B, B dash A, A, B, B dash A. So we constructed this whole figure, but we want the area of only A, E, D, C, B, A. So this was the expression for the area of this whole figure from here to here, right? But we have subtracted the area of this from that, this from that, and this from that. That gave us the area of this, right? So anybody has question on that?
No, sir.
Did everybody understood how that area
Yes, sir.
was, the expression was calculated?
Yes, sir.
Yes, sir.
All right. So in this figure, first what you did, you divided, you had this figure A, E, D, C, B, A, and you constructed certain triangles, rectangles, one triangle, this one was this triangle, this rectangle. So you calculated the area of this whole figure, but you want the area of only this traverse, right? So you subtracted the area of this triangle, this rectangle, and this rectangle, and that will give you the area of this figure, right? Now let's see the each small figure area, how we can calculate that. Now E dash E, D, D dash E dash. So what is this? E dash E, D, D dash E dash. E dash E, D, D dash E dash. So this figure, right? This figure, this trapezoid is this one. So what we said that trapezoid was that we will multiply two parallel lines. So D dash D and E dash E are two parallel lines, and their height is D dash E dash. So E dash, this line which is parallel to D dash, so E dash E plus D dash divided by 2 multiplied by height, which is the y-axis, D dash E dash, or E dash D dash. Do you got that point?
Yes, sir.
Yes, sir.
All right. So in terms of coordinate values, the same area, what we have expressed in this equation, how we can do that? E dash E, this is the length of x-axis because y is constant along that line. And D dash D is also the distance along x-axis because y coordinate will remain whether it's point D dash or point D, right? So both are x coordinates. So for example, E dash E we call XC and D dash D we call XD, right? So XC plus XD by 2